Well, I think a good idea might be to take a close look at that capacitor, which is hidden right there. Just in case we can see the value, it's going to help me. Yeah, no, we're not going to see the value on that. So this end of it looks more or less okay, but the other end, looking a little rough in there. And we can see one end is clearly connected to this terminal here. And that runs a wire down to the terminal strip. And a wire leaving the terminal strip, suspiciously disappearing behind this output transformer. So I'm willing to bet that's exactly what's connected there. That's the primary or secondary side of the output transformer. Now, is there any hint as to which side this is? Any obvious hint offhand? Like a wire disappearing to the speaker. I don't think so. Hard to see what's going on down there. Well, that's the hint. Okay, so the capacitor is either on the primary or secondary side of the output transformer. One side, the banded side, is connected to the transformer. Not that that's going to help much. The other side, what's it connected to? It's got to be, I would imagine it's connected to this terminal here. Yikes. Quite a schmozzle. Could this be ground? Could this be tied to the chassis? Well, let's take a look at that possibility, because it would be helpful in determining what capacitor that is. Since I can't see the value, probably when I look at the schematic, we'll see it can only be one capacitor. There's only one that's hooked up to the output transformer. Let's see. Okay, just put that there. I think it's going to fall. Okay. Are you grounded to the chassis? I believe it's this terminal. Nothing happening. The other side, just for fun. So that's a 1300 ohms. Maybe that's a helpful hint. That could be the resistance of the winding of the transformer here. Okay, so we believe I'm in the vicinity here. If we go on the secondary side, there's no capacitors involved. So it's not going to be on the secondary. It's going to have to be on the primary. Oh, a red wire and a... Yeah, as much as I don't like relying on these colors, because see here it says black and white. Yeah, I can see two wires coming out of that transformer. They both look yellow. In fact, all the wires look yellow. I don't see a red one. But there is a yellow wire that is connected to that terminal strip that is connected to the capacitor. So we're looking at C9 or C18. C18 is grounded. We didn't find a ground on one side. C9 is attached through this resistor R15, and the tone control, which you can ride up and place a ground right on the bottom of it. Let's try that experiment. Okay, let's try that. This is under the assumption that the tone control works. Okay, just clipping this onto the chassis. Where's my little guy? Where's the little guy who holds up my meter for me? I don't know if this is the right one. I think this guy is the wrong one. They have two guys. There's the other guy. Okay. Check first. Something's not quite right. Nothing like a reliable meter. The clip lead is no good. For some reason, how did that happen? So I will tie it in a knot. Add it to my collection of knotted clip leads here. Let's check this one. Red one. Okay. Put that on the chassis. Check it. Okay, we made it all the way to 0. Okay, checking either side of the capacitor again. There's 1400 ohms there. And I think this is the other side of it. Open. Okay, now this is the tone control here. You can see the way the wires are connected to it. So I'm going to, oh, it's sitting on, oh my gosh. That's really hard to turn. All the way this way. So these two should be shorted. Hey, is anything happening when I do this? This is another way to test it. It's trying to get to a 0 there. 0. So this is connected to here. Is that right? To here. No, I've got it totally wrong. I'm totally wrong. One side is connected to the chassis. The other side would be connected to this point, maybe. Well, then we should move this to this point. Sometimes when I'm in the middle of doing this stuff, I start saying to myself, do I still know what I'm doing? Have I lost track? Well, I can't get a 0 to come. So this maybe is not the capacitor. Why so unstable? It's not going to do a 0. It's going to be 200 ohms or so. Not going to make it to 0. Now, I could cut it, pull it out, see what it is. I can match the size, put it back in. I never know what capacitor it really was, but I'm really anxious to come up with a reason for this radio to hum. So, would that even be a reason? Well, we don't really know what capacitor it is yet, so I can't ask that question. You know, the thing about a hum is there has to be a hum in the radio for it to show up in the speaker. Okay, let's leave this one alone, and we'll ask the question, is this guy in the right place? You know, one of them goes to ground. You can see that. The other one goes to this terminal point here, which has on it a large resistor, large wattage resistor, brown, black, green. Brown, black, green. Or is it black, green, brown? It could be black, green, brown. And a brown colored resistor. How do you put a brown paint on a brown colored resistor? Well, all I see is black and green. Could be a brown band up here. Well, we know it's black green, so we know that's a 0. We don't know anything. We don't know anything yet. Many other wires connected here, including a wire going up to the power transformer, and this green one. Where's it going? This is one of the reasons I gave up on the other radio, was these wires. On the other radio, they're so stiff, it cannot be flexed, and this is very flexible. Maybe that's a replacement. It's crazy flexible. Well, these are all flexible. Maybe they're all replacements. All this blue stuff. So that's stiff. That's stiff. Stiff. So I think maybe somebody, not only did they do these capacitors, but they've also done a lot of the wires, which is something I wanted to stay away from. It all looks original way down in there. Flexible wires with rubber, like rubbery cover, is unusual in this vintage of radio. I'll bet you they got replaced. Now, back to what I'm trying to do. I'm trying to figure stuff out. Take a close look at that. There's something unusual there I just noticed. So, here we are. Get something to poke with. The connection we're interested in is the one with this brown resistor coming to it right here. Interesting thing is, the whole connection can move. You can see it's moving these wires. I'm thinking maybe not everything is connected at this point. Just seems oddly loose. Anybody else loose? That's a little bit loose too. That's solid. I would expect these connections to be solid. They're on a strip. This guy's very loose. Now, what I could see... What did I actually see? Wow. I think the connection is good. It's just loose on the piece there. Let's wiggle the capacitor here. Yeah, it certainly seems to be soldered in. So I think everything is soldered together. Thought for a minute maybe they didn't get this soldered. Now the back of that resistor, this long resistor, is it cracked open? I don't think so. I don't think it's cracked open. I mean, it looks pretty darn good, really. Here we can see it now. Black and green. You can guess brown at the start. Brown, black, green connected to the positive side, the negative side of this capacitor. Okay, let's give that a go. I'd really be surprised if whoever did that made a mistake. So we have the two positives tied together. We have the other capacitor going to the chassis. And we're left with this one, C11. Okay, C11 we saw earlier was an 8. C11 8, but there's a 22 in there now. Much bigger. This one goes down and connects to here a bunch of stuff. It's R11 right here. Let's see what is R11. Does it match? Where's the R? Here's the R's. R11. 1 million. Yeah, it matches perfectly. Brown, black, green. Okay, so it would look like the capacitor is connected correctly. So it's not a lack of filtering, certainly not by these capacitors. Could it be a bad number 80? Could that somehow overwhelm the radio with hum? That even though the filter is strong, it can't beat back the problem coming from the 80. We can tube test the 80. Pretty sure I can tube test an 80. Okay, let's try that. Okay, number 80, a 4-pin tube. I don't think there's any other versions of a number 80 tube. They're all 4-pin. So I have this set, but let's just double check because I haven't done that. Number 80, 5 volt on the filament. 73P00, 73P00, and 6000, 6000, 25 on the cheater. E is the plate. We are in business. There's 2 plates in here, fat pins there. There we go. So there's a message here in the listing, a little letter F, and that means there'll be a short encountered probably on setting number 1 on this control, and that's normal. And that's quite common in rectifiers, that there's such a thing, such a short. Here we go. See what happens. There's the short. You can see the meter go right over for that. That's normal. Good. Now, rectifiers and diodes. All we got to do is get up past where my finger is here. There's a little spot here that says rectifiers OK. Okay. Low. Okay, now we also do plate number 2. That's the other half of the tube. Same test. Much higher. So this side of it is this half of the tube is just in the good zone, barely. But the other half, no. It's working, but it's not up to snuff. Well, we'd have to try another 80 in the radio to see if that somehow eliminates the hum. Could it be having the two these are 2 tubes in one? Could it be that just having that out of balance is introducing a hum in some way? There's a voltage difference in the radio that shouldn't be there. I don't know. Okay, I'm gonna have to look for another 80. It's the only way to deal with this. 80. Do I have any 80s? I think I do. Let me check. Well, my tube notes, my tube listing says I have 3 80s and they're all dead. But I have another radio here and there's an 80 in it. So I pulled it out. Let's check it out. No idea if this works or not. We're still set for number 80, so we'll just go right in. Just go right in. There we go. Maybe you notice the pilot light dim briefly. That's a hint that it's heating up. Both sides heating up. Okay. Seems like well, I guess it's identical. Here we go. Any shorts in the tube? Just on setting number 1, where it should be. Checking rectifiers and diodes again. Got to come above where my finger is. Well, we're in the good on that side. Plate. We're in the good on this side. So I've got a good testing 80. So that gives us a chance to try the radio with a different rectifier tube and see if the hum is done. I would give this about a 10% chance of success. Because I really, okay. I'm going to get this radio ready to play with a different tube in it. And we'll do it. Okay, so my theory here is an unbalanced rectifier tube is creating the hum. Okay, no idea if that's true. Let's plug it in and give it a go here. Now, tuning, on and off, tone. Okay, it's off at the moment. Applying the power. 118 volts with the dim bulbs in. There we go. Okay. 107 volts, 108. It's going to go down, I'm sure, though. Look at here. 101, 97. Where's the hum? Let's give it full power. What's with the unsteady volume? Where's the hum? Well, there's still a hum there. Now, is the hum much less or is it the same? It's out of the cabinet. Maybe I'm having trouble hearing it when it's out of the cabinet. Whew. Okay, no trouble hearing that. Well, I finally did it. I've ruined the radio here. Well, it's not a noticeable hum. Stick your ear in it. I gotta slip it back in the cabinet. See if we can hear the hum now. Okay, ready for another test. Volume down. Power on through the dim bulbs first, just because I'm a chicken. Full power. Yeah, the hum is much more pronounced. Much, much more pronounced. So my theory down the drain on the unbalanced 80, didn't have much faith in that theory to begin with. At least now I know I have a good 80. Number 80. We'll just have to go back to that capacitor and maybe I'll just take it out and change it at this point. So I just have a construction deal with this kind of radio. Get it close enough. You can see there's a board that runs up here and has a whole bunch of these style of resistors on it. And I have a few here. Basically a junk box. Here's a huge one. So these guys are built with these end caps and a lead coming off. End caps and a lead. So I think what they've done is they've placed this on this board here. Whoops. Up here now. They've placed a resistor on the board. And the lead has come through to the other side of the board, and then that becomes the terminal to which they're connecting various things. I don't think that's actually a terminal strip. I think it's a board with holes through which you push these leads. And that explains why this one's a little loose, because there's no terminal to it. That's my thinking. The green clip lead is my mnemonic, not really a mnemonic, but my method for remembering where the capacitor has come from. Because goodness knows I'm going to clip this out and get a phone call and then never remember what I was doing. Let's see if we can cut the capacitor and nothing else. I'm hoping I can test it. So a little bit of lead here. There's not much. Okay, hopefully that was the capacitor I just cut. Yep. Now why wouldn't somebody replace this capacitor? 0.03. 200 volt, 0.03. End cap looks like it's coming out here. Let's give it a test. Let's find out what the story is on it. So this tube tester works by, does two things. It'll measure a capacitance using a bridge, but it also will test the amount of leakage through the capacitor. The capacitor looks like this is going to be a leaker, I'm sure. Okay, so it does it by putting a voltage on it. I got it set to 25 here, but it's really 50 volts. And when I throw the switch, we can watch the eye over here. If there's current flow through the capacitor, the eye closes. So at first it's going to close, but then as the charge builds, the eye will open. The good capacitor, the eye opens. And a bad capacitor, it never ever opens. Oh my gosh, look at that. We can go up to 150 volts here. And it's not opening. So it's not the worst. A really bad capacitor, it can't take 50 volts on this test. So this is a moderately bad capacitor, but a new one is going to go in regardless. Obviously I'm not going to put this back in there. Okay, so we're going to install a 0.03 in there. Oh, let's look at the schematic and just see if we can find a 0.03. Okay, we'll take a look at the listing for capacitors and we'll see how many. Here's a 0.03, a 0.03. So that's C6, C8. C6 or C8? Okay, let's see. C9 and C10. Wait a minute. How can that be 9? This is 9. How can that be 10? This is 10. Oh, it's R10. R10. R. C9. So what did I say it was? C8? That? Oh, wait a minute. Let's. Oh. Is that right? C8 or C6? C6 or C8? Well, this is a critical capacitor. If it's this one, it would be critical. And C8 or what? C. Oh, I forgot already. I must have really drink more coffee. C6. Where's C6? Anybody see C6? C5, C7, thought that was C8, 7, 8, that's C9, so C6 would be, there's C6. So what is C6 doing? So C6 is connecting the audio from the volume control onto the grid here. Oh, so what if it's leaky? You would think if this was implicated that changing the volume would cause some kind of change in the hum, but it doesn't. Plus, I bet you C6 is somewhere else anyway. We can maybe even find it right on the volume control. C8. Well, this is a really, I mean, if this is it, C8, C9, why do I put 9 here and 10 there? Why didn't I go 9, 10? Is there any other C possible 8s around here? 16 way down here. Oh, these are all high numbers here. So I just go way back. Looks like a 5, 13. How did they number these? There are some numbering conventions, like you start in the top corner here and you work your way across like this, numbering. So you C2, C, looks like a 3 there. Okay, well, this is it. That's a critical one. You don't want this one leaking. This guy will leak some of this 55 volts through to this grid. That's not good. How you get a hum here? Well, you know, it's a grid, so any little thing on the grid is going to come out the speaker. Well, I guess this is it. That's a really important one to change, if that's the one the guy left. But I saw the capacitor connected to here. Didn't I? I don't know. I'm lost. It's a 0.03. C10, C9. C10 and C9. 0.05. 0.005. 600, 600. This is rated at 200. This is rated at 200, isn't it? I'm looking again. It's rated at 200. So we actually have this number to look at too. C6 is at 0.3 at 200. It has to be C6. C6 off the volume control. Well, that might explain why it's connected to a terminal strip. There'd be wires coming back from the volume control. Okay, let's just investigate that a little bit before I go ahead and change it. Is this capacitor? We can check up against this grid. We can check back against the volume control. Let's go for the volume control. Should be looking on one side of C7, work the volume control down to the ground and see the ground on C6 rather. See the ground on it by turning the volume control. That would give some proof. Okay, we'll do that. Why am I so concerned about this? I just like to know what's going on. At least I'd like to have something in my head that makes me think I know what's going on. That's good enough for me. Where did our okay, so the volume control, it's up here. No, it's down there. Some wires coming back. Those are the power wires. Where's the volume control wires? Speaker, come in through here. Hey, they head underneath here. Maybe they head straight to there. Okay, so if that's the case, then this might be the lead right here that we would measure against ground. Here. One side. Good. Okay, then we adjust the volume control. I'm getting a 0. Ha-ha. Ha-ha. So it is the volume control capacitor, which goes to, typically it would go to the grid of the oh, look again. Look on the schematic again here. This will go right to the grid. Yeah. So, you know, if there's anything funny going on here, your uncle. Okay, let's change that capacitor and give it a go. Okay, so I'm going to use this lower, it's a 100 volt capacitor here, and I just want to check it before I commit to it. 35 nanofarads is 0.035. That's 0.03 to me. Good. I'm going to put that in, and should be glory bound. Okay, another hum test. Volume is down. Okay, we'll turn the power on through the dim bulbs. There they go. All is well. Full power, so we get the full hum. I'm going to stick my ear down here to hear it rather than put this back in the cabinet. See what happens. Okay, so I'm giving I'm giving this a generous 15%. I can already hear the hum. 15%. Quickly dropping to 0%. Let me stick my head there. She's just a humming away. Well, again, the hum could be due to a tube situation here, which I already know it's really ugly trying to do something with those tubes in terms of testing them. I can't test them for their hummability anyway, other than swapping them out. Yeah. Okay, I'm going to stop and just think about that, but this might be the end of the video. This might be the end for this radio, in fact. I just don't think I can overcome the hum sound in it. Yeah. I'll go away and do some thinking. So if this is the end, thanks a lot for watching to this point. This radio will go away, and I have the next radio. I have the next radio just sitting right here, waiting, trying to get in here. Yeah, I don't think I can defeat the hum. I can't seem to control myself. So what about this capacitor? Which is a kind of capacitor I think is quite reliable in an old radio like this. It's definitely been a replacement. There's no doubt about that. So I looked at the size. The size is 0.1. 0.1. So I looked on the listing, for the parts listing for the radio. There is no 0.1. There's no 0.1, but there's quite a few ones. 1 microfarad, but no 0.1s. So what's going on here? Good question. So I took a look at this tube. This is a 6A7S. I looked in my tube substitution book. 6A7, 6A7S are the same tube. Here in my RCA manual, 6A7, 6A7S is listed. So I can rely on the pin arrangement here. This capacitor goes to ground from this pin, which is pin number 1, 2, 3. Pin number 3 on the diagram is G3 and G5. So this is a mixer tube, has many grids in it, and those two grids are going to be screens. Screens. So the purpose of this capacitor is to quiet things down on the screen circuit at this tube. Could it be trying to quiet down a hum and it's not having success because it's a 0.1 and it should be 10 times that size, a 1? Good questions. I'm going to jump on the schematic now that I know that this is the screen. We are going to take a look and see if we can find that capacitor on the schematic. So this is the tube, 6A7 with a little s afterwards. And we are on pin 3, which is not numbered, but it's the screen. You see it here, 90. Let's go and follow it. Voila! C4. C4, there it is. Trying to quiet the screen circuit, the whole screen circuit for all these tubes. So this is also very important to prevent feedback and other stuff. C4, what's C4 on the list? C4 is a 1. It's a 1. There is no 0.1. Now, if they're doing this properly, if this was supposed to be a 0.1, there would be a 0 in front. So you put a 0 point. And the reason for that is because the decimal points disappear very easily. It's a drafting issue, reproduction issue. So the convention is to say 0.1. So there's no 0 here. Was that convention in place back then? I don't know, to be honest with you. But it doesn't look to me like any dot is missing from here. You can see little dots down here and all over the place. I think it's a 1. I think that capacitor is a 10th the size it should be. And a 1 is a little bit hard to come by. Well, I'm going to consider changing it to a 1. Okay, 1 microfarad capacitor is in. Let's give it another try here. Good so far. Well, I can hear a hum. See, it's exactly the same. Well, there is one more capacitor. I can't imagine how that would be causing a hum. But we have one up here. I might as well do this one. And now that's got to be part of the antenna arrangement. Let's see if I can figure out which one that is exactly. Okay, time for one more try. Got a new capacitor stuck there. I give this a 1% chance of working, or of helping out with the hum. I'm being generous at 1%. Okay. Same hum. Oh, what is that? This one, the cap on the tube has come loose from the tube itself, so it's kind of stuck on the grip here. If you were just to kind of casually, twist and pull that off, cap will come off the tube. But let's see if that fixed this little problem. Watch this, the hum will be gone now. Now, wouldn't that be funny? Still humming. Good. Just put together a very quick antenna here. Just more wire.
The automatic 55 wins that he was a few years ago. But that was a really interesting story I thought came out. Like how that dynamic plays out. If nothing else, it's LeBron tipping his hand that he's sticking around.
Hey, maybe I'm directional.
As he should. He's still a really good basketball player. All right, 855-212 for CBS. Got a lot of football to get into. Want to touch on the MLB lock-on?
Well, it certainly is working okay. It's a possibility of doing an alignment on this radio or something like that. But I really think that's it for now. The hum, yeah, I don't know. I don't know. Apparently I didn't know right at the start either. Thanks a lot for watching, and we'll do something different tomorrow.